So children, in the last class we had discussed about the various operations or the arithmetic operations that we can apply on the matrices. Now over here in this class we will be discussing about the term that is identity matrix. So some of you are well aware about the thing that is what is an identity matrix. But those who don't know, you should first learn about the identity matrix, then we will be able to discuss the program and you will be able to understand the thing in a good manner. Okay, so see, the example for an identity matrix is like this: if the diagonal elements of the matrix is equal to 1 and all the other matrix, all the values under this matrix are equal to 0. Okay, like in the diagonal you can see that on this diagonal 0 comma 0, 1 comma 1, 2 comma 2, right? All the three diagonal elements are over here 1, but other values that we have over here are equal to 0. Okay, so this is the way you will be able to identify an identity matrix. In identity matrix, always the diagonal elements from left to top left to the bottom right will be equal to 1. That means all the diagonal elements are 1. If all the diagonal elements are 1 and other elements in this matrix or any other matrix is equal to 0, in that case the matrix is known as your identity matrix. Okay, and one thing to note that in this concept of identity matrix, you must learn about the thing that if the diagonal elements are equal to 1, only then the values or the identity matrix is possible, otherwise not possible. Suppose over here it is 1, over here it is 0, and over here it is 1. So if one of the value is 0, it is not an identity matrix. So if all the diagonal elements starting from top left to the bottom right, the value should be equal to 1 only. Okay. Now coming over to the to discussing the program in this. In this program, first we have defined the class and then we have defined the main function over here. Next thing we have did that because we are dealing with the matrices, we need to find or we need to calculate the value for rows and columns. So we have taken two variables of rows and cols. This cols is for the column, and we have set one boolean variable, that is flag, which is equal to true. Also we have declared an array and we have initialized the value for the array, and the value reads like 100, 010 and 001. So we have provided the value. The same matrix that we have formed over here or we have drawn over here, same is taken as the input over here, right? So this is the way you will be getting the inputs for the array. Okay. Now next thing to do is to find the number of rows and columns. So to find the number of rows, you will write down a dot length, and to find the number of columns, you will write down a of 0 dot length. So in this way, you will be able to find the value. So see, if you are looking for the value for rows, you have to count the number of rows and number of columns. In this matrix, you will see that the number of rows over here is 1, 2, and 3. And from the column side, it is 1, 2, and 3. So 3 column and 3 rows are there. So value for rows and value for column is 3 over here. Okay. Now one thing is mandatory for a matrix to be an identity matrix, that the matrix should not be a square matrix. Okay. So square matrix is one more term which you will hear. Okay. So if what is the condition for the matrix being a square matrix is that if the number of columns and rows is not equal. So if the number of rows and column is not equal, it is not possible that a matrix can be an identity matrix. Okay. So it is an example for a square matrix and the process will end over here. Alright. But if this condition is right, that the rows and columns are equal, in that case you will come into the else condition and you will be doing what? You will be checking for two conditions, right? In the very first condition, we are checking whether or not the value for the index and the diagonal elements is equal to 1 or not. Okay. If one of the element is not equal, see, if we have to compare the diagonal elements, in the diagonal element, the concept is that the rows and columns should be same. Like this one is on the index number 0, 0. This one is on the index number 1, 1. This is on the index number 2, 2. Right? So you can see the number of rows and columns in each of the diagonal elements is equal. So we have checked for the condition over here as I is double equal to 0, and we have checked whether a of ij is not equal to 1. Okay. In this condition, if the value of is not, of a of ij or the diagonal element is not equal to 1, in that case, what we will be doing, we will be taking false value in the flag. That means what? That matrix that is having a diagonal, one of the diagonal elements is not equal to 1. Okay, so in that case, the matrix will not be an identity matrix, right? So that's why we have stored in the flag, we have stored false over here, and then we have break down from the if condition, and finally the next condition will be checked for this. In the same manner, every condition or every diagonal elements will be checked with this particular condition. This particular condition will check whether the diagonal elements are equal to 1 or not. Okay, this was the first case. One more case is there that we have checked for the diagonal elements whether diagonal elements are equal to 1 or not. But once we have to check also the thing that if the other non-diagonal elements are there, all the non-diagonal elements should be equal to 0. So for that we have checked the condition, and see, this 0 is having a different value. That means the number of row and column over here is not the same over here, right? So in this 1, 0 will be the 1. This is 0, 0, and what will happen in this? This is 1, 0. Okay. So that means that the non-diagonal elements will be having this condition of I is not equal to j and a of ij is not equal to 0. So if both the condition is true that the value is not equal to j, that I is not equal to j, so it is not a diagonal element, and if it is not a diagonal element, it should be equal to 0. And if it is that e of a of ij, that means a element over there is not equal to 0. That means the condition is again wrong for the identity matrix. See, we have to check for two conditions, whether the diagonal elements are 1 or not, and the non-diagonal elements that we have is equal to 0 or not. So for diagonal elements we have this first condition, and for the non-diagonal elements we are having this condition. So once we have checked for both the conditions, and if nothing will happen, like if this is true or this is true, in both the cases the value of flag will be false over here. And earlier we have stored the value of flag as true over here. Okay, so if any of the condition is true over here, the flag will be having value as false. But if nothing happens from both these conditions, that means the matrix is a square matrix, or the matrix is called as a identity, not the square matrix. Okay, because square matrix is not having the rows and column equal, but identity matrix has the rows and column equal. Okay, so at last we have checked for the if condition where value for flag will be provided. The value for flag over here is true. Okay, because our value satisfies, our matrix satisfies all the condition, because the value for these diagonal elements is equal to 1 and non-diagonal elements are 0 over here. So in over here flag will be true, and if followed by the true is there, that means that the condition is right, and this statement will be executed, printing the thing that given matrix is an identity matrix. Okay, so in this way you will be finding whether a matrix is a identity matrix or no. Okay, all right, only this much in this video. In the next video we will be discussing one more type of matrix.